For decades, scientists have debated on what exactly is an acid and a base. Sure, we know that an acid is something that tastes sour, and a base is something that tastes bitter, and that when combined, they form salt. But scientists wanted a deeper explanation, something that delves deeper into the fundamental atoms of these chemicals. And through the years, 4 scientists have worked to understand the natures of acids, bases, and acid-base reactions. From their hard work emerged 3 defining theories: the Arrhenius theory, Bronsted-Lowry theory, and the Lewis theory. Let's start with the first theory to be conceived, the Arrhenius theory. The Arrhenius theory, otherwise known as the theory of electrolytic dissociation, was developed by Svante Arrhenius in 1884. Now, according to him, an acid is a substance that contains a hydrogen atom and produces H+ ions in an aqueous solution, while a base is a substance that contains the OH hydroxyl group and produces OH ions or hydroxide ions in an aqueous solution. Think of it this way: acids create H+ ions and bases create OH negative ions in aqueous solutions. Side note, an aqueous solution is any solution with water, H2O, as its solvent. We can also discuss the process of neutralization. In this process, the H+ ion in an acid reacts with the OH ion of a base to create water. The Arrhenius theory was able to define what an acid and a base is. But these definitions don't exactly apply to all conditions. For instance, let us look into the reaction between ammonia and water. The ammonia acts as a base while the water acts as the acid, and they react to form ammonium and a hydroxide ion. The ammonia is considered a base despite it lacking the hydroxide ion. This does not conform to the Arrhenius definition of a base. Although the Arrhenius theory fails to define all bases and acids, it did help in the creation of more general theories. Next up, we have the Bronsted-Lowry theory. In 1923, both Johann Nicholas Bronsted and Thomas Martin Lowry independently presented their own definitions of an acid and a base, serving as extensions to the Arrhenius theory. Between the two, though, Bronsted presented the more comprehensive theory. Their works resulted to the Bronsted-Lowry theory. In this theory, an acid is defined as a substance that gives off an H+ proton, or a proton donator, and a base is a substance that accepts a proton, or a proton acceptor. It also defines an acid-base reaction as the transfer of an H+ proton from an acid to a base. Let's take the reaction between hydrogen chloride and water. In this reaction, the hydrogen chloride acts as the acid and the water as the base. Now, the H+ proton of the hydrogen chloride gets attracted by the lone pairs existing in the water molecule, resulting in H3O+ and chlorine. The Bronsted-Lowry theory brings forth the concept of conjugate acid-base pairs. These are 2 species or molecules that differ by 1 proton. For instance, let us consider the reaction between ammonia and water. In this reaction, the ammonia is the base and the water is the acid. The water molecule donates an H+ proton to the ammonia, and it results to ammonium and a hydroxide ion. The ammonia and ammonium are conjugate acid-base pairs. If you were to look at the subscript of the hydrogen atoms of both molecules, you would notice that ammonium has 1 more hydrogen atom than ammonia. That makes them pairs. But note that the 2 molecules have to be of the same species to be a viable pair. In other words, the 2 molecules have to be made of the same kinds of atoms. Ammonia and ammonium are said to be of the same species, for they both consist of a hydrogen, a phosphate, and an oxygen atom. The acid and base of a conjugate acid-base pair also have names. The acid is called the conjugate acid and the base is the conjugate base. The autoionization of water can be described using the Bronsted-Lowry theory. Ionization is the process in which an atom or a molecule forms ions in order to attain a positive or negative charge. In the case of the autoionization of water, water reacts with its fellow water to ionize and create equal numbers of hydrated hydrogen ions and hydroxide ions. According to the Bronsted-Lowry theory, this reaction is an acid-base reaction. A water molecule donates an H+ proton to the other water molecule. The water molecule that donated an H+ proton becomes the hydroxide proton, while the one that accepted an H plus proton becomes the hydrated hydrogen ion. But the Bronsted-Lowry theory wasn't the only theory to develop around these times. Next up, we have the Lewis theory. In 1923, about the same time as Bronsted and Lowry, Professor Gilbert Newton Lewis presented the most comprehensive theory yet, the Lewis theory. And yes, this is the same Lewis who made the Lewis dot formula in chemical bonding. An acid is defined to be any species that can accept an electron pair, and a base is any species that can donate an electron pair. We specifically say electron pair and not just an electron. This kind of bonding is called a coordinate covalent bonding or dative bonding. Now, what is this exactly? In a simple covalent bonding, say between a hydrogen atom and an oxygen atom, each atom contributes one atom to the bonding. But in coordinate covalent bonding, the two electrons come from only one atom, which is in the form of an electron pair. With this, neutralization gets an additional definition. Let us consider the reaction between boron trichloride, BCl3, and ammonia. Boron trichloride acts as the acid and ammonia as the base. They react to form Cl3BnH3. In boron trichloride, the boron has only 6 valence electrons, which means it can accept 2 more electrons or an electron pair. According to the definition of the Lewis theory, boron trichloride is an acid. On the other hand, the nitrogen in the ammonia has a full set of 8 valence electrons and an existing electron pair. According to the Lewis theory, this is a base. The electron pair of the nitrogen is drawn to the boron, and thus a bond is formed between the boron trichloride and the ammonia, resulting in the product Cl3BnH3. The three theories each presented their definitions of an acid, base, and the reaction that occurs between the two. And although the Lewis theory has proven to be the most comprehensive of the three, it could not have existed without the foundations built by its preceding theories. One cannot exist without the other, and thanks to the hard work by these astounding scientists, acids and bases have never been more crystal clear. Thank you for your time, and we hope this instructional video has helped you better understand acids and bases. This has been Daulayan and Portrait Garcia, signing off.
C'est si bon quand on se plie, de rire et que la pluie pleure elle aussi de joie, se parle. C'est si bon quand on se parle.